Hi folks, welcome to Outlier Detection with Machine Learning in the Elastic Stack. My name is Emmanuel and I am a community engineer with Elastic. If you haven't heard of the Elastic Stack, it's a whole stack of software very famous for observability and web monitoring, and more recently also for security use cases, and of course for search, many use cases in search. At the heart of the Elastic Stack, there's an open source analytics and search engine called Elasticsearch. What that means is essentially you can throw numbers or text into it, and it's particularly good also for time series data. And you can very quickly search that, you can ask it questions, and it will return answers very quickly. You can also aggregate the information, and then from then on, you can visualize that information and search through it in the graphical user interface, Kibana. That's where we'll be spending a lot of today. There are also other parts like beats, logstash, and application performance monitoring, or code tracing, that have to do with web monitoring and observability, which we are not focusing on today. The vast majority of the stack, if you download the stack, you can use a lot of it for free, completely for free. Even if you're a commercial company, there is no time trial or stuff like that. But with machine learning, you do have to have a subscription, so it's a commercial feature that you have to pay for. However, if you go and use it on our SaaS, Elastic Cloud, then you will probably be able to get much cheaper rates. And at the moment, machine learning is included in the Elastic Cloud trial. So if you start your 14-day trial, you can try out everything that I'll be showing you today, actually completely for free. But after that, you will have to pay for it either in Elastic Cloud or by getting a subscription if you download the software. So, why machine learning, and why did we develop a machine learning module at all? Currently, we've noticed that the data analysis workflow is pretty complex. So you start by collecting data, then by exploring it, storing it, visualizing it, and then you maybe train a model with libraries like scikit-learn, and there's tons of possibilities here for libraries. Then you productionize this, so you run this model on something that allows you to predict what the classes for new and incoming data would be on a much more massive scale, and then you iterate. You improve the model and you look at its accuracy, just iterate on it and develop it further. Now, what we attempted to do for a particular set of use cases was make this easier to do, because this way you have to do, if you wanted to do this on data in Elasticsearch, you would have to constantly get it in and out of Elasticsearch, which is fine. It's a data store, and that also works. That's how a lot of people use it. But it's just not convenient. And for certain use cases, we think you can do a much better job if you use a much faster job, more importantly, if you use the Elastic machine learning module. So to that end, we built a bunch of features. Elastic already has quite a lot of features, like in just pipelines, and a lot to support ingestion of data that we won't be getting into today. But there's in particular a transforms feature, which you can think of as essentially being able to build a pivot table around your data and summarize one index into another index. Then we have, of course, Kibana for visualization, for kind of representation step and exploration step. And we have analytics, which we'll be focusing on today. So today I'll be showing you Kibana visualizations, and we'll be looking at outlier detection via analytics jobs. Then further on, you can do unsupervised learning and inferences, but we won't be looking at that today. Altogether, this allows you to do pretty effective machine learning on your data. For what use cases did we build this? Because I did say this is for specific use cases initially. So initially this was built to deal with operational data. So things like how fast are the pages on my website, individual routes, and Are they being particularly slow at any given point? Or things like business sensitive data. So for example, orders coming through in different regions if you run that kind of company, or hotel bookings going up and down. So anything that's time series data and that then has a numerical aspect. However, that's kind of anomaly detection. However, nowadays we actually have just classification. So we have binary classification. We have two classes, either say true or false, or good or bad, or a fraud or not fraud in the case of fraud detection. But nowadays we also have multi-class classification, and so these fall within supervised learning. So you have to go and label a part of the dataset, and then you can train the model on that part, and then it attempts to predict the rest of your data, and you can see how accurate it is and so on. But we initially started with unsupervised learning. So we would look at patterns over time, such as how your web pages were performing or how many orders you were getting in over a certain period of time, and we would try to detect a pattern, and then if something went outside of that pattern, we would alert you. And this is more useful than just setting thresholds, because we would also learn things like weekend patterns. So if your orders increased significantly over the weekend, that's not an anomaly if they do this every weekend, whereas with the threshold alert, it would be much harder to do this. What outlier detection attempts to do is look at certain fields in your records and see which ones are on the most extreme ends of the distribution scale. So let's say if you had a price field, then which are the cheapest ones and which are the most expensive ones. And so this is what we'll be looking at today. So demo time, let's go and have a look at Jupyter and the Airbnb data for New York City that I prepared in there. We'll clean and upload that to Elasticsearch. Then we will run an outlier detection job in Kibana, and then we'll play around with that a little bit and explore the data. And we'll also build a little dashboard. All right, let's dig into the Jupyter notebook. Before we do this, we should get into Elastic Cloud. That's where all the data is going. So after you sign into Elastic Cloud, you'll be met with a screen that lists all of your current deployments, like so. From here, you'll need to click Create Deployment. We simply want Elastic Stack. IO optimized is fine. You can select your favorite cloud provider. We support Azure, Google Cloud, and AWS. You have the cluster name. For production, I recommend at least 2 fault-tolerant zones, and you probably need an appropriate amount of RAM for your production data. If you're just playing around, you can set it to 1 zone and just 1 GB of RAM. You will need to enable a machine learning node, most important here. For Kibana, we should leave that as is, and we can disable the APM node because we're not going to be doing any code tracing or web observability today. And we hit Create Deployment. I already have a deployment running, so we won't wait for this. But just to show you, once you have your deployment running, you need to copy this password before you close the screen. Because there's no way to get it. Otherwise, if you do close the screen without getting a password, click on Reset Your Deployment Password. Okay, so let's dig into the notebook itself now. We know where we will be sending our data to Elastic Cloud. The data comes from inside Airbnb.com, and it's about almost 46,000 Airbnb listings. Do some standard imports using pandas, NumPy, and most importantly, the Elasticsearch Python client to upload the data. Reading the CSV, there are a number of fields in the data that are available to us, and what we'll focus on today is how many people the listing accommodates, rough latitude and longitude of the listing URL, the number of bedrooms, and the price. And we will also use the date of how long has the host of this listing been on the Airbnb platform. We do a little bit of data cleanup, things like if there's a letter in the bedrooms, we replace it with 1, which is sensible defaults. Because we'll be using the how long you've been a host as a timestamp field to display all the records in the timeline, all the listings, we want to remove records which don't have that field. There's only 3 or 4 of them. Kibana will deal with it if there are gaps, but it just makes visualizations easier. And we clean up the price and the host acceptance rates, make them floats. And just a sanity check, yeah, that's the right number, almost 46,000. Now mappings. So here, first we have the settings for the index. And the interesting thing here is that we set a default pipeline. So in the schema itself, we have an at timestamp field, and we want Elasticsearch to generate that for us. So I'll show you how to configure the pipeline in a second. You can just throw documents into Elasticsearch and it will guess what the schema is. However, here it is, and in general, it's better to specify the schema because, for example, latitude and longitude would just be guessed as floats, but here we have a geopoint and we want to play around with the map visualization, so we want location to contain latitude and longitude, and we need to explicitly specify geopoint here. So what we're doing here is yielding the data. We're making a generator. That's because the Elasticsearch Python client has a function, helpers bulk upload, which batches up items in, I think by default, 500, and batches of 500. And it can take a list or a generator, and minimal memory use, we go with the generator. This is how you can hide credentials. So just put them in a bash file or in a shell file, source it before you start Jupyter Notebook, and then start the notebook. Okay, now create our index in that way. So as I said, there is a timestamp field in every record, and we use the special ingest pipeline field to say, okay, in that field, put the time the record was put into Elasticsearch. So in addition to saying the default pipeline has the timestamp pipeline when we create the index, this is the definition that we need to send along. This is the code. And you'll have access to the notebook, so you can look at all of this code and copy it. All right, and then we upload the data. Now, we're not going to wait for it to upload. We're going to create an index pattern. So why do we need an index pattern? Well, with Kibana, you can do things like field name autocompletion when you search for things, and even the values within a field makes searching a lot easier. It makes visualizing easier. It makes timeline visualization a lot easier. Okay, so we create a pattern. It's catching the index we want, so we're happy to do that. And we're going to use host sense. So what we're going to see there is how many listings you have based on how experienced you are with the platform, which will be kind of interesting to see. Okay, so the data should be, yeah, let's finish uploading. So we have our index pattern. So let's go to the Discover view. Okay, now, well, I know the data is 13 years, so look at the last 13 years. And it was quite interesting. So you can see people who got in after 2014 have the most listings, but then after 2017 that drops off again. And this is how visualizing the time field can work in Kibana. You can set whichever field you like to organize the records by. And then we have, of course, the actual data, prices, bedrooms, and so on. Right, let's now do some machine learning. Let's go to machine learning, and we will want the data visualizer. Select an index pattern. And this index pattern. This is a useful tool to just help you see the distribution of values in your various fields. For example, number of bedrooms, as the most have 1 and 2. Most acceptance rates, most hosts have accepted nobody, quite a few have accepted everyone, and quite a lot have accepted half their guests exactly, and so on and so forth. Number of reviews is as you would expect. Most records have less reviews. And price is curious. Most listings have between $95 and $100. So it's just an interesting tool to look at your data. Okay, let's get on to outlier detection. So I clicked on data frame analytics up here, and we're going to create a job based on the index pattern we created, and we want it, of course, to be an outlier detection job. We need to select the variables by which we're going to determine whether records are outliers or not. And I want to, let's say, look at bedrooms and price. I'm pretty interested in the extremes for those two fields. Yeah, included fields, bedrooms and price. I'll prop up the memory limit slightly. Sometimes it's difficult to estimate exactly how much memory run is going to take, so I like to increase it a bit. It's got a gig of RAM anyway, so it's not going to run out. I'm going to call the index demo outliers and get the job going. First, the source data is going to be re-indexed to make sure we don't mess with that. And then we are going to run the outlier detection, the actual analysis. That's phase 3. And then we're going to write out the results. So whatever outliers we have detected, we need to pop them in our new index demo outliers. Excellent, let's view the results of the job. Okay, 21 bedrooms. Let's see the price for this. Okay, for $200, that's probably a typo in the bedrooms. Now, there are some issues here besides 21 bedrooms. There are posts with no availability, listings with no availability at all. There are listings for $1. We should clean this up a little bit. Of course, you can clean up your data in Jupyter, but I'll show you. Let's say that you've already got your data indexed and you don't want to bother re-indexing it, or you can't for some reason. So what can you do, and how do you clean this up? So we're going to use a query to filter the data before we analyze it. So I want properties that are available at least 1 day from the coming year, that have over 3 reviews, 3 or more reviews, and that cost $11 or more to stay in. And I think it might also be wise to make the number of people a property accommodates part of the variables we analyze, because if it costs like $50 but it can accommodate 10 people, and if it has 1 bedroom but it can accommodate 15 people, like those are extremes that are interesting. So let's include, so we're getting the number of people it accommodates, the number of bedrooms it has, and the price. Alright, pop the limit on the memory back up a little. Okay, and we're gonna call this demo outliers clean. We run the job. Yeah, that's looking a bit better. There's definitely properties with higher availability, and let's show the price as well. At least at a first glance, looking from just a sample of the results, yeah, that's reasonable, or more reasonable than before anyway. Great, okay, so let's start visualizing things. If you click on the menu here, and then click on dashboard, we are going to create our first dashboard. Let's first save it, and give that a name. Now, let's just add one visualization to begin with. We'll make that a visualization of the outliers, and let's do something simple like a visualization of the price. So how many records have a given price or fall within a given bucket? Let's set it to minimum $10 intervals. Okay, excellent. So let's save this and add it to the dashboard at the same time. Great. Now next, let's add a search. Always in the dashboard, besides visualizations, we can add a records display. If we go back to Discover, we should be able to see the records that our job produced. Indeed, we can switch between the raw data and the outliers. So let's have a look at one of those records and what they actually end up looking like. So here is the outlier score, or how weird is this record according to the criteria we've asked for. Okay, so far so good. Then let's save the search so that we can see our records when we filter the entire dashboard. We can not only see a visualization, but what's behind it as well. Great, and now we can add that to the dashboard. Say add demo search, the one we just created, and here we are. Now, this is all right, but it's pretty hard to read, for me at least. So how can we make this easier to read? If we go back to the search, we can actually pull out specific fields. So for example, should we start with perhaps the neighborhood? Property type would make sense. The price would certainly make sense. We could get the number of reviews. Oh, and a listing URL is definitely going to be useful. And I would say likely the outlier score. All right, great. Now, if we save this, that's going to change it on the dashboard. But you know what? That's nice, but we could do a little bit more here. For example, the listing URL, it would be nice if we could just click that and open the listing. And what would also be nice is if we could get kind of alerted visually if an outlier score was high. Like an 882 is much more interesting than a 026. And this is the whole point after all. How could we highlight this? If we go the very bottom to stack management and we go to index patterns, we should be able to see the index patterns that have been defined so far. And what we want is to look at the outliers pattern. Okay, so here there are things like what is a number, which field is a number and which field is a date. But the listing URL is currently a string. However, we can additionally in Kibana apply a format. And if we say that it's a URL and we wanted to open a new tab, this will make them clickable links. As for the ML outlier score, we could do something to highlight it. What we can do is color. So we could say we don't really mind what it looks like between 0 and 0.8. That can be the default. And between 0.8 and 0.9, it's mildly interesting. So let's say we give it a light blue background. And between 0.9 and let's say 0.95, that's more seriously interesting. So let's give it a darker background. And then finally, 0.95 to 1. Okay, those are pretty strange records, so we want to know. We want it to be very obvious. We're going to flip the color scheme. Excellent. Right, so if we refresh the search, we can indeed see that links and the outlier score is highlighted. Fantastic. Now if we refresh our dashboard, we can see here that the listing URL is indeed highlighted. The outlier score coloring is working. Now, the display isn't working that great, so let's say we decided we don't care about number of reviews. Perfect, we can edit it straight from here. Let's save that. Everything's working well here. Now let's add a map. If we click here under Kibana Maps, you can say create a new map, and we'll arrive at this screen. A map of the world based on OpenStreetMap. So let's zoom in a bit on New York and start adding some data. Let's display the outliers. We could have them clustered, but that's not particularly inspired or interesting. So I'm going to say limit the results to 10,000 and give me the actual individual results, because we can do more interesting stuff with that. Call that outliers. Now for each outlier, we want to know a few things: how many people it accommodates, how many bedrooms it has. The listing URL would be interesting. And the outlier score, definitely. Neighborhood and price, property type. Why not the rating? All right. So now when we hover over one of these, we'll get a lot more information. Fantastic. We can do a lot more than that, though, to visually let us find outliers on the map. If we click on the icon, we could use a building icon instead. So there's lots of little houses, which is amusing, but not that useful. However, if we change the fill color to be based on the outlier score, and we make it a garish, strong visual gradient based on that score. Okay, so we can see that some properties are not particularly strong outliers, and again, others are. The red ones are very strong outliers. Cool, and let's increase the symbol size a little. Awesome. Okay, we can save that layer. And let's also add the raw listings data. That'll be far too much at the moment, but we'll use it later. Now we want to know quite similar information here. Listing URL, neighborhood, price. And we'll just make the same changes here. So we'll say the buildings. There is nothing to change the fill color based on them, because it's raw data and no outlier score. Okay, great. Now there is a time selector. The reason that layer isn't displaying anything is because there have been no new records added relating to the last 15 minutes. So we want to see records from 13 years ago or up to 13 years ago. And that definitely displays. An interesting feature here is fit the data. So this will change our zoom level to fit the map to the data that we have. Just pretty nifty. Okay, so there are a lot of blues and greens that are not so interesting for us. So if we say we want only those with a higher outlier score, okay, that is a lot better, and we can navigate that much more successfully. So let's have a look at some of these records. What are these, for example? Ooh, okay. It's a very high outlier score indeed. And I already have these opened in tabs, just because I have to put in dates, and it'd be boring for you to have to wait for me to deal with the UI. So this is $1,000 a night for a really cramped studio. You can see what this is looking like. There's only this one room. So it's definitely an outlier. But we could have found that out probably just by sorting by price descending and bedrooms ascending. So highest price for one bedroom. So it's not that interesting. But what if we could find unusually cheap places that would house a larger number of people? So let's have a look. Shall we say, let's have a look in the Bronx. Okay, that one is interesting. So it accommodates 15 people, only has 2 bedrooms, and the price is $285. So if we open that, we get this very emotive listing. Indeed, it does seem to be a large house with lots of places to sleep, some more imaginative than others. But if they say you could fit 15 guests and the 2 bedrooms have 6 beds in them, then clearly this is geared towards groups of friends. We're being very coronavirus cautious and going several months ahead to March 2021, but it is indeed quite cheap. So maybe we would book that and have something to look forward to with our friends when things are a bit more relaxed when it comes to travel. All right, back to the map. Now, you could say, well, we could have found these without outlier detection as well, just by browsing through the listings and filtering them in various ways. And that is true for some of these results. But let's see what happens when we plot all the raw data and we don't use the outlier detection. In fact, we will leave the outliers on. Let's just overlay the raw data and see what happens. All right, so there we go. How would we ever find anything useful in this sea of icons? And so this is exactly what makes outlier detection so cool. And also, of course, the ability to search by outlier score. Now let's hide this raw data. Now, even if we don't filter by outlier score, just a visualization that separates into greens and reds and blues and so on, that's already very, very useful. So let's see, here we have a red one, entire townhouse, accommodates 12 people with 3 bedrooms. New York is interesting. And the price of only $78 a night. So if we were to click that, we would end up at this listing here, for which I've already put in some dates to check the price. And it does look really good. So I'm guessing the host was just feeling quite generous. Indeed. So there we go. We found this just by coloring the icons depending on the outlier score. All right, let's save this map and add it to our dashboard. And here we can say edit, and we want to add a map. And we probably want to make that a little bit bigger. Cool. Now we could filter the entire dashboard. So for example, we could say that we only want to see higher outlier score properties and everything updates immediately. So for example here, in the records, this So for example, here the records display has changed, the price visualization has changed, so a lot more of those have a higher price, because that was one of the fields we were analyzing, so that's not a surprise. And here in the map, we can see that those records have been filtered as well. So you can build really powerful dashboards after you run outlier detection. We've run some outlier detection jobs in the machine learning module, and we've explored the data and created a dashboard in Kibana. If you'd like to learn more, the ML documentation is honestly quite a good place to start. So run up a free node in the Elastic Cloud free trial, the 14-day trial, and play with that. We also have a lot of material on things I didn't touch on today. So if you want to see examples of multi-feature classification, check out this language identification blog. And if you want to see a demo of anomaly detection in machine learning, check out this YouTube video. If you have any questions, you can reach me on Twitter and email. I've been Emmanuel, and this has been Outlier Detection with Machine Learning in the Elastic Stack. Thanks for watching, thanks for your time, and I hope you stay safe and stay healthy.